Hi, hello, I'm Kiran Kumar from Nature of Physics and Art. Today I will start from part 1, that is capacitors. See, in which I wanted to explain first dielectric substance. So dielectric substance is a insulating materials. So dielectrics are very useful. The dielectrics takes place between the plates of the parallel plate capacitor. Then capacitance is increases. How capacitance increases we will discuss step by step. Now it is dielectric substance. K is the dielectric constant. It is very useful concept in the capacitors, and dielectrics also arranged between the plates of the capacitor in series combination and parallel combination. So many applications it has. Okay, so dielectric substance examples. So what is the dielectric substance? It is a insulating material. Okay, so that is electrically bad conductivity. That's why that is does not conduct any electrical current. Okay, examples. Okay, so example is glass, mica, paper. These are the best example for the dielectric substance. See now, here dielectric substance does not conduct any current, but it can transmit the electric field. See, this is the dielectric substance which takes place between the parallel plates. Okay, so like a parallel plate capacitor, this is positive charged plate and this is the negative charged plate. So electric field is from the positive charge to the negative charge. Here this dielectric substance allow the electric field. That's why it transmit the electric field from the dielectric substance. But in metals, electric field is zero in the substance. That is metal substance. This is dielectric substance. In dielectric substance, electric field E is transmit but does not conduct any current. Remember these points. Okay, and next in dielectrics, so this is the nucleus. Around the nucleus, electrons are revolving in a circular path. Okay, so nucleus is the positive charge. This is the nucleus. Okay, and electron is the negative charge. Okay, the electrons are tightly bound with the nucleus in the dielectric substance. And dielectric substance are classified into two types. First one is polar dielectrics and second one is non-polar dielectrics. So first I wanted to explain the polar dielectrics and then non-polar dielectrics, and what is the difference between them we can discuss. Okay, so now here only polar dielectrics. Okay, so for polar dielectrics, the dielectric which is made of a polar molecules, the dielectrics which is made of a polar molecules. What is polar molecule? In polar molecule, the center of the positive charge and center of the negative charge separated by certain distance. That is, the center of positive charge and center of negative charge does not coincide in a molecule. That molecule is called polar molecules. That substance is called dielectric substance. Okay, so here initially I am taking polar dielectric substance. This is the polar molecule. So the substance which has the many polar molecules. See, this polar molecule has the negative charge and positive charge. These are separated by certain distance. That's why these polar molecules have the permanent dipole moment. That's why polar dielectrics has the permanent dipole moment. Dipole moment P is equal to Q into 2A. Okay, so the charge The product of charge and distance between the charges is taken as dipole moment. What is dipole moment? A system of two equal and unlike charges are separated by small distance is called electric dipole. Electric dipole momentum. It is the product of charge and distance between the two charges. It is the product of charge and distance between the two charge. See, this has the permanent dipole moment because of initially they are not coincide to each other. See, this is at ordinary condition of a polar dielectric substance which has initially dipole moment of a molecules in a polar dielectric substance. See, this is ordinary condition, permanent dipole moment has the molecules. Okay, so whenever the polar dielectric substance takes place in the uniform electric field, that is uniform external electric field, that's why the dipoles are aligned in the direction of electric field. See, there is a small difference between the dipoles in a molecule of the substance. See, here dipoles negative, positive, clearly in one order comparing to the ordinary condition. But this have the permanent dipole moment. That's why here positive charge and negative charge never separate to each other in a molecule. So polar dielectric substance, okay, no use in a dielectric substance. That's why non-polar dielectric substance are useful comparing to the polar dielectric substance. Useful only, but comparing to non-polar dielectric substance, okay, here less we are using the polar dielectric substance. Next, non-polar dielectric substance we will discuss step by step. Just a second, I will clean it. And one thing here, example of the polar dielectric substance. So the examples of the polar dielectric substance are, so water, okay, alcohol, okay, NH3, HCl. These are the examples for the polar dielectric substance. One thing remember, it has permanent dipole moment and the center of the positive charge and center of the negative charge separated by certain distance does not coincide. That molecules is called polar molecules. That substance is called, okay, polar dielectric substance. See, this is ordinary condition in the presence of electric field. That is just aligned in the direction of electric field, but dipole momentum is remains same, okay, and also does not separate the positive charge and negative charge of the polar dielectric substance in a uniform electric field. That's why we will use the non-polar dielectric substance takes place in a parallel plate capacitor. Just a second. Now, continuation about the non-polar dielectrics. See, what I said to you, polar dielectric, the dielectric which is made of a polar molecules. Polar molecules, center of positive charge and center of negative charge does not coincide. Here, non-polar dielectrics. Okay, the dielectric made of a non-polar molecules. Okay, what is non-polar molecules? The center of the positive charge and center of the negative charge is coincide in a molecule. So for polar molecules does not coincide. Here the center of the positive charge and center of the negative charge is coincide. Simply see the molecule in which the center of the positive charge and center of the negative charge is coincide. That molecule is called non-polar molecule. That substance is called non-polar dielectric substance. See, here positive charge, negative charge separated. And there is no permanent dipole moment because of here both are coincide to each other. So in this situation, the net dipole moment is 0. Okay, so that the examples, that is H2, N2O2, next CH4 we can write CH4. These are the examples for the non-polar dielectric substance. So net dipole momentum is 0. That's why it does not have the no permanent dipole moment. Okay, see, and continuation, this is the non-polar dielectric substance. This is non-polar dielectric substance. Non-polar dielectric. Okay, at ordinary condition. See, already I said to you, the molecule in which center of positive charge, center of negative charge coincide, that is called, okay, non-polar molecule. That substance is non-polar dielectric substance. Okay, so this is ordinary condition, nothing but at room temperature. And continuation here, electric field is applied, that is uniform electric field. That's why here the center of positive charge and center of negative charge separated. Now this second condition here, that molecule have the dipole moment. See, reason is what? Here positive charged plate and this is the negative charged plate, and electric field from the positive charged plate to negative charged plate. So electric field is E. So we are taking E naught is the applied electric field. That's why the dipole in which the molecules in which positive charge, negative charge separate and has some dipole moment. Then the electric field is increasing. See, electric field is increasing. Now we have external uniform electric field. That's why what happened here, positive charge, negative charge is separated from the molecules of a non-dielectric substance. See, dielectrons are separated. So here negative charge and that side is positive charge. Why negative side? Negative charge left side. So this is positive charged plate attract the negative charge of the molecule. So that is negative charged plate that attract the positive charged plate. That's why here E naught is the applied electric field and EI is the induced electric field. So this is the induced electric field which is opposite to the applied electric field. So we can write here net electric field. So net electric field is E. Okay, so here E which is equal to E naught minus EI. So both are in opposite direction. That's why here minus sign is taken. EI induced opposite to the applied electric field. This is net electric field. See now here net electric field in this substance, that is E is equal to E naught divided by K. Okay, so E is equal to E naught divided by K. So here we can write like this, net electric field E is equal to E naught divided by K. So due to the dielectric substance between the plates of the capacitor, net electric field is decreased by K times. So net electric field which is equal to E naught divided by K. So whenever electric field is decreases, net electric field from the electric potential EVD relation, E is equal to V divided by D. So here electric field is directly proportional to the potential. So net electric field is decreases, then electric potential also decreases. From the parallel plate capacitor, C is equal to A epsilon naught by D. Okay, so here whenever the potential is decreases and capacitance is increases, so we can write from the simple formula, capacitor C is equal to Q divided by V. Here C is inversely proportional to the potential. Here electric field net is decreases. So this is simply I am writing minimum. Okay, so then here electric field is minimum, then potential also minimum. So minimum potential, nothing but capacitance is increases. So here potential is minimum and capacitance is maximum. That's why due to the dielectric substance, that too non-polar dielectric substance, the capacitance of the capacitor is increases. So the net electric field E is equal to E naught divided by K. This is the basic equation I wrote here. Okay, and then here electric field intensity is decreased by K times comparing to the applied electric field. That's why that is electric field intensity net is decreases from EVD relation. Electric field intensity directly proportional to the potential. That's why here potential is minimum, then capacitance is maximum. That's why capacitance is increases while dielectric slab takes place between the plates of the capacitor. This is very interesting topic is completed. Due to the dielectric substance, the capacitance of the capacitor is increases, that is C dash, which is equal to Kc. So what is that? C dash, which is equal to Kc. Okay, so what is K here? Dielectric substance. So this is the K. K is dielectric substance. That's why capacitance is increases. How many times? K times. C dash, we can take here C dash is the capacitance in a medium. Okay, what medium? Dielectric medium. C is what? That is parallel plate capacitor. Already I gave you C is equal to A epsilon naught divided by D. Okay, so then we can write here, okay, C dash is equal to Ka epsilon naught by D. So that C dash is equal to Kc only. C dash is equal to Kc only. See, parallel plate capacitor, C is equal to A epsilon naught by D. Then C dash is equal to Ka epsilon naught by D. So K times increases. So then here C dash is equal to Kc. Okay. So thank you. Please like my videos and subscribe my channel and share to your friends, and do comment about my videos also. Thank you.